Okay, this is the second part of the review on being able to solve quadratic equations. So today we're going to look at how to solve using the quadratic formula. And then we're going to look at how to use our calculators to come up with the solutions as well. So first, make sure you know this formula here, which is known as the quadratic formula. It even has a song. I'll post it on our Schoology site. But you should just have it memorized. Okay, so for the first thing you got to make sure you remember whenever you're solving using the quadratic formula is the equation has to be set equal to 0 first. And when we evaluate it, we're going to make sure we follow order of operations. So by going ahead and putting this one right here, we're putting it in order. So everything has to be on the same side. The whole equation has to be equal to 0. So I have negative k squared minus 10k minus 8 equals 0. Now, so I don't have so many negatives. If I multiply everything in this equation by negative 1, I would get k squared plus 10k plus 8. And you can do that, and that's just so you can get rid of some of the negatives. Okay, so now we're ready to go. So now I want to identify what my a is. It's the coefficient of k squared. My b is the coefficient of my linear term, which is positive 10, and my c is my constant term, which is positive 8. Now I'm going to go ahead and put it into my formula. So now we're going to go ahead and substitute into our formula. So it says x is the opposite of b. So if b is positive 10, we want negative 10. Plus or minus, remember that comes from our conjugate roots. Square root, and now we want b again, but this time we're going to square it. Minus of 4, which is a fixture, it never changes. And then a times c. Don't forget about including your signs if there are some that are not positive. And then it's all over 2 times a. And now we follow order of operations. So you're going to go ahead and evaluate what's under the square root first. So we have 10 squared, which is 100, 4 times 1 times 8, which is 32, and 100 minus 32 is going to give us 28. So we have negative 10 plus or minus the square root of 28 all over 2. Now just as an aside, square root of 28 can be simplified because the square root of 28 is 4 times 7, and remember we can split up the square roots of the factors. So square root of 4 is 2, so that means this would simplify to 2 times the square root of 7. So here's what we have now. Negative 10 plus or minus 2 square root of 7 over 2. Now this is not simplified. It is a correct answer, but we want to make sure we simplify again. Here's the thing to remember. This denominator here, we're going to be looking for common factors, but it has to be a common factor to both the first term in the numerator and the second term in the numerator. And when you have square root terms, remember we only can divide by things that have common coefficients, not something under the square root. So since 2 can't go into 10 and 2, I will divide negative 10 by 2, which gives me negative 5. I still have my plus or minus, and 2 divided by 2 is 1, which leaves me just the square root of 7. So what this is saying is that one solution is negative 5 plus the square root of 7, and the other solution is x equals negative 5 minus the square root of 7. And that's because quadratic equations are always going to have 1 or 2 real roots, or they're going to have 2 imaginary roots. And how we can tell that is from what's underneath the square root sign, which is the b squared minus 4ac. And basically what the discriminant says is that there's three possibilities. If it is a positive number greater than 0, there are 2 real solutions. If it's exactly 0, there is 1 real solution or root. And if it's less than 0, remember, that means you're getting a square root of a negative number. Well, square roots of negative numbers are imaginary, which means you have 2 imaginary roots. Okay, let's go ahead and look at the second problem. And so remember that when we're solving this one, we can't solve it until it's set equal to 0. So we have 6x squared minus 3x plus 9 equals 0, putting everything on the left. Now I'm going to put it in my formula. So x is the opposite of b. So a is 6, b is negative 3, and c is 9. So if b is negative 3, the opposite of it is a positive 3. Plus or minus the square root, b squared minus 4 times a times c, all over 2 times a. And now I'm going to substitute those numbers in. So I have negative 3 for b squared, and then I have 4 times 6, which is a, and times 9, which is c, all over 2 times a, which is 6. So now I'm going to follow order of operations. So I'm starting to work first with what's under the square root. Negative 3 squared gives me 9, and then 4 times 6 times 9 is going to give me 216. So I have 9 minus 216, which is going to give me a negative 207. Well, what does that mean? If I stop for a second, if I have a square root of a negative, that means my discriminant is negative. Remember we said that if the discriminant is negative, I'm going to have 2 imaginary roots. So I know that for later. But let's go ahead and finish. 2 times 6 is going to give me 12. And now remember, off to the side, I'm going to go ahead and I'm going to simplify that 207. Well, 207 is divisible by 9. 9 goes into it exactly 13 times. 9 is a perfect square, and so when I do the square root of 9 times 13, it gives me 3 square root of 13. I still have my negative there. So when you're doing the square root of a negative number, remember, square root of negative 1 is I. So the square root of negative 207 is considered to be the square root of negative 1 times 9 times 13. So we break it apart. What's the square root of negative 1? I. What's the square root of 9? 3. What's the square root of 13? It's irrational, so it's just the square root of 13. So we would write that 3 plus or minus the square root of negative 207. We usually write the I after the real number coefficient, and then we go ahead and put the remaining radical all over 12. And again, just make sure you simplify. Can anything divide 12 as well as both of these terms up in the numerator? Well, yeah, all of them are divisible by 3. 3 divided by 3 is 1. 3i divided by 3 is 1i. Still leave my square root of 13. And 12 divided by 3 is 4. So our two solutions are imaginary. 1 plus I squared of 13 over 4. 1 minus I squared of 13 over 4. So let's go ahead and look at solving by graphing. Now the thing about solving by graphing is this is not always going to give us our precise answer. It's really an estimate, and so let's go ahead and write that. This is only an estimate, and it cannot find imaginary zeros. So first we're going to need a calculator. If you don't have a calculator, we'll go over this in class. So this is our equation that we're looking for. I've already graphed it, but I'm going to go ahead and show you how I'm doing it on my calculator as well. So I've gone ahead and I graphed it. So what I'm looking for, remember, is where my y value has a 0. And so my y value has a 0 on the x-axis. And so what I'm looking for when I'm solving by graphing is I'm always looking for what are the x-intercepts. The x-intercepts are known as my zeros. And the zeros are also known as the solutions, and sometimes they're even called roots. So all 4 of those names sometimes are interchangeable, but just we call them different things based on the context. So let's go ahead and look at how we find out what those are. But if you look really closely, you can see this one is close to 2, but not. This one is close to 2, but a little bit over. This one looks like it's really close to negative 1, but I'm not too sure. So on your calculator, the first thing that you would do is you would actually go ahead and type in the function. Okay, so here I've already gone ahead and done it. Another thing is to make sure that you're using the correct zoom. So if it doesn't quite fit, you can go ahead and you can go to menu. You can go to window. And on this one, I chose zoom standard. Sometimes you have to use other zooms. Okay, so this is what you end up with your graph. And so now we're going to go back to menu. So I'm going to choose menu. And when I choose menu, I'm going to do analyze graph. And I want to analyze the zeros because 0 is the same as the roots, which is the same as finding solutions, etc. Okay, now it's going to tell me lower bound. So I'm going to look for the one on this one. So it means go on the left side of the 0. So I click, and now it's going to change it to upper bound. And so I'm using a TI Inspire, by the way. I'm going to click when I'm to the right of 0. And now it's going to tell me that that 0 is at approximately negative 0.924. So it wasn't at quite exactly 1. Now, to find the other one, I'm going to repeat. So menu, analyze graph, 0. Now this time, again, lower bound is to the left, upper bound's to the right. My second solution is at approximately 2.160. And my second solution is at approximately 2.160. Hope you enjoyed the puppies.